you can have a multi-cloud strategy, but what I wouldn't have is a multi-data cloud strategy. If you're going to have data in one cloud and data in another cloud, and you're going to need to combine those on a regular basis, that's where the expense is really going to come. And maybe that is a trade-off that you want to like agree to as a company, but
Welcome to the Ocean of Technology podcast,
where we bring on real experts to talk about
real technology, real deep.
I'm Nate Samuels.
And I'm Joshua Williams.
And we're your hosts.
Let's jump into it, and you can kind of give us a background of who you are.
Yeah, happy to, and appreciate you having me on. I just wanted to say, happy to be on. These are just talking about my own individual points, not representing my company, of course. But I've spent about 20 years now, which you can probably tell from the gray. I'm starting to be the gray beard in the room now, where I used to be the young tech, punk. Now I'm the old guy in the room. I've been doing data and AI applications, engineering, kind of the full spectrum from a deep technical lens as well as from a application lens for almost 20 years across a variety of industries. So I started off in an aerospace company that did all the signals processing for air to ground communication. So it was a lot of understanding how signals propagate through the air and making those calculations very quickly to allow the air traffic controllers to talk with planes and so forth. So, and that's how I got my start. And from there, I started to build out, very large data sets on Bigtable, back when Bigtable was first introduced by Google in 2005. So I'm dating myself again, but really just at the beginning of the transition from very structured data to very unstructured data, and how do you handle it through Bigtable and other types of techniques now. I've had the opportunity and privilege of working with a lot of great companies. You can probably see from my LinkedIn profile, and I currently lead a team of AI engineers who work with customers on deploying applications to solve very hard business problems across a variety of different industries, but including healthcare, government, as well as media communications and others. So happy to be on. Excited to talk to you a little bit about my passions around this area, since I wake up every single day thinking about unstructured data and how do we make sense of it, right? So it should be good.
Yeah, and in terms of like unstructured data to you, like what would what is unstructured data to yourself?
Yeah, I mean, the technical definition of unstructured data is, data that may have an internal format, such as a video file, a Word document, and so forth. But the text or the images in that file haven't been structured in any kind of way. They haven't been any kind of like applied reasoning to it to structure it. So in the world of big data and databases and other things, typical databases have a very structured application to it. So for like a sales record, you would have first name, last name. You would have the column, and then in that row, you would have stored the value. So it's a very typical structure. When you're talking about something very complex, like, for example, a medical document, there may be a format to it, but it is unstructured in that there is paragraphs of text in there, lots of medical specific terms and other things where there's really been no semantics applied to it yet, which that makes it unstructured. Interestingly enough, when I deal with clients, and I deal with Fortune 500 companies, governments, so forth. The vast majority of the data that they have is stored unstructured. It's like 80% is some of the recent things that I've seen, kind of estimates, but most of what we deal with is some sort of text that's very unstructured, and so that gives you a lot of complexity in how do you manage, store, apply some semantic reasoning or something to it, like make sense of it, like how do you understand it, find it, index it, and so forth.
So from a general blueprint standpoint, what is kind of the roadmap for, I guess we're talking text right now, so
Mhm.
unstructured text to actual transformative data? Like, what's the general roadmap?
Yeah, there's a couple of different paths, but what we always work with is we always start with what is the business problem? And usually it focuses somehow on being able to accomplish a task or understand or predict where something is going. That will create some sort of value or cost efficiency or something like that. I mean, we can see this in numerous applications such as processing. Healthcare payer records in order to be able to pay out claims faster, be able to understand, customer sentiment within a customer care type situation where people are calling in and so forth. The typical path that we see customers is so they start with what is the problem we're trying to solve. If customers don't start with that and they just jump into the tech, we often find that it's easy to get lost, right? There's n number of like n log n almost now number of technologies out there that will allow you to store and process unstructured text, but it's really less around the technology and more do you want to accomplish with it. What we typically see now is we see a lot of our customers going with a kind of hybrid architecture, if you will. So having both structured or SQL type data store alongside an unstructured or distributed data store. So examples of these could be things like databases like Oracle, Synapse, Postgres, those types of things where you can store things in a very structured way. And then unstructured ones are like, Databricks, Snowflake, and then the cloud hyperscalers all have kind of their own flavor of that. And it's essentially the two different ways. To get to insights, it takes a process from a technical perspective to, identify the text or whatever unstructured information you're looking for, put that into going through some sort of ingest process, meaning you're moving it from one place to another, you're combining it together and then making it available to machine learning to then be able to mine and then produce some sort of insight. And it's a typical like left to right. You can kind of think of that type of architectural diagram that we have. More recently, a lot of our customers, what we're working with them on at these architectures is allowing them to store all of these different unstructured texts together and then applying reasoning on top of that. Sometimes it's called schema on read, but it's really saying, I don't know what I want to extract out of it, so I'm not going to apply a false kind of data model to it up front. We're going to store the unstructured data as we get it, combine it in smart ways, but then allow machine learning applications to run over top of that and make sense of it, depending on what lens we want to apply it, what problem we want to have it, and so forth. So that's kind of the typical architectural pattern that we're seeing. And can certainly dive more into depth. There's a lot of good articles out there around these types of hybrid architectures that are out there, but that's what we're seeing a lot of.
Peter, are you familiar with CI/CD in terms of like cloud environments? Would you say
Continuous
that?
integration, continuous development, that yeah.
Correct, exactly. So would you say that when you deal with unstructured data, it's almost like that, except you're just doing it with the data, where you have continuous data inflow and continuous insight outflow sort of thing?
Yeah, it's a good analogy for sure. We certainly see that, and the here's one of the things that we see as a result of that, right? That a lot of the companies that I work with are used to working with very large data warehouses, which have very structured data, and they've got the cubes and star schemas, like linking everything together. And so they come out with that, and they say that's our system of record for sales, personnel, customers, et cetera. When you have a CI/CD type pipeline, what happens is you continually get new data and continually analyze it. You tend to get better answers, but they're different than the ones that are stored from a batch process or ones that are legacy and so forth. So absolutely, CI/CD is a good analogy. And then the outcome of that, the challenge that we see with a lot of customers, they say, well, wait a minute, like that's a different number than we're getting from our system of record. And so now you have to kind of help them understand, well, you're getting a better, more accurate, more up-to-date information than you were in your old system because of that CI/CD pipeline. So there's an outcome. There's always you can't get get everything for nothing, right? There's always a engineering trade-offs that you have to go through when you're doing that. But yeah, absolutely. And we see a lot of the things like the agile methodology that folks are using. They're using a lot of the pipeline tools that are out there right now for them to do ETL on these unstructured data sets and so forth.
And one of the things that I've noticed a lot within cloud is that the optimization, right? And one of the things I know with data is that moving data is very expensive, especially when you have such large amounts of it, right? So
Hmm.
I see these new platforms coming out where it's going from data lakes and data warehouses and becoming data lake houses, right? What's kind of
Yeah.
your what's kind of I've spoken to a couple of data scientists, a couple of data engineers. They're kind of still confused about that. So can you kind of go and explain what this data lakehouse is and what as the actual benefits that companies are going to actually pull from this?
Yeah, absolutely. This is what I was talking about before about that kind of hybrid architectures, right? When we think of like a data lake house, it has both a SQL and unstructured type of data store for us. And what it typically does, it goes through a process where it takes data individually and combines it and then makes it a more curated set for machine learning applications. And it goes, typically there's kind of 3 steps to a lake house architecture. And there's lots of good architectural diagrams out there that show this same pattern. But it goes from a kind of an uncurated, which is more raw storage format, which a lot of folks call like their bronze, right? So you think of bronze as, less precious a metal than say gold, right? So bronze data set, and that would be your really uncurated. You would then apply some transformations to that, some sort of algorithms or whatever in order to make it, a silver, which allows you to combine your unstructured data sets together in a way that you can better make sense of it, and you're providing some sort of data model or something at that level. You then combine that with your kind of SQL data sets, which then becomes your gold. And so in your gold one, you have a curated set of all of your data, structured and unstructured, together to allow for machine learning applications to better understand that data, to inform applications, they run faster, et cetera. That's a typical lakehouse architecture. You can then query that with both SQL and machine learning applications. And, in my world, a lot of our customers use like Power BI to then dive into the gold um, data lake and then be able to do that. And there's a variety of technologies like Databricks, Snowflake, et cetera, that do that. Okay, all that being said, right, is like that's kind of the typical pattern. In terms of expense, copying data and so forth can be very expensive. Really, the ingress egress charges that you get in a cloud is where it's typical. So what we recommend to our customers is like pick one for your data store. Like there's ideas of like, and that's fine. There's plenty of companies that do that, and there's good reasons for doing that. But that's where the majority of the cost comes from. Where you have a reduction in costs, and a lot of the data scientists, data engineers that work on my team, they by following a lakehouse architecture, it actually reduces the amount of time they have to find data, get data, curate data, et cetera. It's already there for them, so they can move right into development rather than this big long process that it used to take to be able to find data, do your analysis, do exploratory data analysis and stuff on that. Like a lot of that is eliminated by moving to a lakehouse architecture.
So I know you brought up a couple of these different tools and technologies such as Snowflake and Databricks, right? So I speak
Yeah.
with a lot of different directors who say, Databricks is more expensive upfront, but it's cheaper over time, while Snowflake is cheaper upfront, but more expensive over time. What's kind of your stand on that?
Yeah.
And what have you seen?
Yeah, it's interesting. I mean, it really depends on the use case and what you're doing. Like, expense versus value, they're two different things. I mean, you're gonna have to deal with data somehow, right? And so what I don't recommend is using both at the same time. I've seen some companies, do that. And, Snowflake is really good for some tasks. Databricks is really good for other tasks. There's general purpose ones that each of the cloud providers have as well. What I would just recommend for your, directors that you're talking with is, pick one and stick with it. And over time, the costs will be normalized, right? Because there's always an upfront kind of startup cost, but over time, as you get more and more usage of it, then that becomes a more predictable kind of linear curve, if you will. So that's what I would recommend. The other thing too is there's a lot of movement. There's a lot of new kind of technology that's coming out. I look at there's kind of safe bets around what is happening right now versus kind of future bets that a lot of customers are doing. For example, there's a lot of folks who are starting to use things like feature data store, like specialized data stores for high-end machine learning applications. But at the core of it, it's still running on pulling from some sort of data lakehouse, right? But there's like vector databases that are now becoming much more popular. There's feature data stores. There's like some specialized ones, of course, graph databases and other things like that. But what I would have customers think about is where is that core data going to live, that core, bronze, silver, gold. Like look at that as your system, right? Your unified data platform for all of your data. And then you can derive the products and everything out from that. And then you can, it's better, easier to calculate costs that way.
Not to throw another wrench in the mix, but now what about private cloud? So
Yeah.
have you seen customers kind of migrating their data over to a private cloud? Are they holding it? Like it doesn't matter, just as long as it's in Databricks, it's fine. Like, what are your
Yeah.
thoughts on that?
Yeah, it's interesting. I mean, I work with a lot of regulated environments where it's a little bit more difficult for them to move to some sort of cloud infrastructure. There's a lot more security requirements, so there's some privacy things they need to deal with, or there's just data they just don't want to leave their prem. So we do see a lot of hybrid, data that is still on-prem versus data that's in the cloud. I usually recommend to customers one or the other, meaning don't do a multi-cloud and hybrid cloud, like do one or the other. Do a hybrid, which is on-prem and cloud, or do a multi-cloud, but don't do both, which is where all the complexity usually resides because you're having to make connectors and APIs fail, things get messed up, things change like very rapidly. So I generally don't do that. Where the majority of the customers that I work with, when they have data on-prem, they are looking for how do they securely do something, in the cloud, in the cloud itself, in order to be able to move that. So I see that those hybrid, over time becoming less and less on-prem and much more in cloud. Just the economics works out better, and the security has gotten much better.
So you've been experiencing this for you've been in this in the weeds for a while now, right? um
Yeah,
and there's something that I've been noticing. So there's some clients, right, that obviously have done the migration already into these clouds, and there's other clients who are actually scared to still put their data within the public cloud. What is kind of your
yeah.
experience on that? Have you seen that a lot, or is that not something you see too much in the healthcare space and life science space?
Yeah, yeah, definitely. A little bit less on the life sciences, more in, I would say, in the provider side. And a lot of it is, it's not necessarily that they're scared. It's more that they have some operational constraints, right? So, like for example, a hospital system, very large hospital system we worked with, they actually have to plan for having no connectivity, no computers, and still operate as a hospital. And if you think about the complexity around the modern, hospital and how it works, right? Even just in the US, at least, the interface between hospitals and payer systems and like how much interaction there has to be with that. they have to kind of plan for and think about those types of contingencies. And so it's really more about being able to balance kind of some of those operational constraints they might have with making sure that they can operate as efficiently as possible for the ideal patient outcomes. Where I'm seeing a lot of providers focus on, for example, is they're thinking about when they have like a longitudinal data set in history, is they put that in the cloud, de-identified, and then they can use that then to help drive a number of different ideal patient outcomes, whether it's predicting, hospital bed usage, or they're trying to understand, how sepsis turns into severe sepsis within a hospital system and one of those indications and so forth. Like there's a number of those types of use cases where they're using the cloud for longitudinal type data and maybe a little bit less for operational data. I'm seeing that grow more and more where they are putting more operational stuff out there. I mean, Epic and Cerner and these, big medical records companies are starting to be more cloud enabled and so forth, which I think is a positive thing overall. So I think it'll enable new and different analysis that we need for health. But it's funny. There's still like tons of data that's just sitting around. I was working with an energy company that still had seismic data that they had on like tape reels for that they had taken from like 50 years ago, and they were literally in like cold storage. And if you needed that data, you had to like call a guy on a phone, and he would like go walk into the fridge and like find the tape. Like it's that was like 2 weeks ago. Like there's still like that kind of stuff out there. So I think it's still in the cloud journey. I think we're still early. Like, I mean, there's still a lot out there that I think we can pull into that. So, but there's generally a sense I think of the customers that I work with, and maybe it's just because I'm at one of the hyperscalers right now. They're constantly talking to us about how do we now move into the cloud because they realize the efficiencies and the value that it drives. So.
That's awesome. So a little bit more niche question. Not sure if you've had a lot of experience in it, but I'm sure you have. Video processing.
Yeah.
So you got all this video coming in now. I mean, the amount of data from video just went like shoo in the past like 10 years probably.
Yeah.
So have you seen any clients kind of talking about that? Like, where is that
Yeah.
going? What's that process look like?
Yeah, it's really that video is really an interesting like computer science problem. Broken down, it's like, uh, the number of frames per second, right? Depending on how it's shot. And the quality of video has gotten much better, which means that as the video quality goes up, the data files get larger and so forth. I work in one of my customer sets is in media, that they only deal with video, right? It's like 90% of their data. I work with sports as well that has a lot of video with it, and you have to extract and pull it. So, I mean, we could talk for days about video because it's awesome. But if you think of video, again, you approach it from kind of two standpoints. One is there's like that raw kind of bronze level storage, just video files as raw form. What I see with customers now is they're taking, for example, on a movie set, they will take multiple angles, multiple video streams, and all of that will be loaded up into the cloud that day, right? As they're shooting, it spools, it records locally, but it also puts it up. That gives the director at the end of the day the ability to look and analyze all of that digitally, right? So you don't have to like load film, like you have to like individual for like you could all look at that right away. So that's a huge value. The other thing is that can then be shipped off to like special effects. So a lot of, for example, movie studios, they don't have they have in-house like special effects people, but mostly it's contracted out. So there's literally thousands, tens of thousands of contractors to support movie development that does a lot of the special effects. So by uploading the video every single day, they can then ship that to the special effects house. They can get started right away. So it speeds up production and it actually ends up lowering the overall cost and improving the quality, which I think we've seen in it. When you look at it from a machine learning standpoint, the really exciting things that are going on is, we've moved from basic object detection within video streams, right? Which is I'm going to analyze a bunch of frames. I'm going to use some sort of CNN or something to be able to compare it to other. And then I could show you, for example, one common use case is how many minutes did my little banner on the inside of a hockey rink as it's being, displayed, like how much actual time did that get within, was it worth my investment of advertising dollars to put that in there, et cetera, right? Like that was like an early use case. We've now gone to much more sophisticated video processing and to the point now where you can actually, generate. So a lot of excitement around ChatGPT in the public. But really, what generative models allow you to do is actually allow you to create special effects, scenes, etc., without having to do a lot of extra shooting, a lot of extra special effects, and so forth that you had had to do before. So the video processing we're seeing, has really gone way up, and we're seeing it more and more. Those because they're getting larger and more complex, and the analysis they want to do is more complex, just naturally being moved to the cloud because that's just an easier, more cost-effective way to do it. And there's tons of tools out there that will allow you to do things, that you don't have to develop yourself that are right there, which is nice. I'm not sure I answered your question. I could talk for days about video, so stop me before like I do that because it's just a fascinating area.
So I guess my question would be, so you have the bronze level input video, right?
Yeah.
Then we want to index it and sort of get to the silver and the gold and then make some sort of transformative insight. So let's say you have like something like that sort of scenario. So like in the case of a hospital, you're in the OR, someone's recording the video, whatever it is. And you want to make a predictive analytics right then and there. Hey, if this surgery is taking more than 15 minutes, there's like a 30% chance of failure. Whatever it is. I don't know. I'm making something up. I don't know if that exists yet, but that sort of idea.
I don't know. I don't know that I want surgery to be timed.
maybe the angle, maybe the angle of like the knife or things like that, right? I know we were looking at sports that had the angle of the arm, but I'll let you answer the question.
No, it's all good. I'm not sure. Maybe not surgery, just because you don't want it to be like kitchen nightmares, right? Surgery nightmares, right? It's like you're running out of time. You gotta. So if they no, but I mean, it's a good question. Like, so the way that we see video handled is slightly different than we see handled text because it really depends on what you want to extract from it. So just take a sports analogy, which I think is the easiest one to understand. Take a basketball game, right? Multiple people moving, the ball's moving. There's video cameras in most professional NBA stadiums that line the ceiling that film the game, and they do semi-real-time processing. They push up to the cloud, they do process, so forth. That shows, number of, and then they do this basic calculations. When they, that shows like, for example, time of possession or shots from where. So you'll see those graphics on, the thing, and it'll be like, in this quarter, they had so many shots, blah, 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 blah. That's all done through video, right? And it's all done processing in semi-real time. The way that you do that is you have to apply analytics on ingest. So you're extracting the entities on ingest. So the bronze, silver, gold is a little bit different. You're pulling in because you have more of a real-time nature that you need to, real-ish time, not true real time, but real-ish time. So you apply your processing on each feed as it comes in to be able to extract the objects, and that result would then go into some sort of silver or gold depending on the application. But what you're trying to do is process as much as possible as the data is flowing into your system. And there's a lot of different ways of doing that. There's cameras that have GPUs built in with machine learning models that will do that at the point of the video hitting the CCD chip, right? And then it fires over to the GPU to be able to do that. Like there's some very real-time stuff that'll do that. We see applications of that in like security, sports, and other things like that. But that's where you want to do that. So the data that's coming in already has some sort of processing or something on top of it in most cases.
So there's one thing that I've been thinking about since I've been seeing so many digital transformations happen within these sports games that you're talking about, right? So as you probably noticed, a lot of the media has been pushing, and there's been a lot of traction gained within sports betting more recently, right? And the thing that
Yeah.
I'm thinking about is, you can predict a lot, right, with this data, right? You're able to see the probability of people making shots. You're able to, correlate that data to old data sets and kind of make predictive models on who you think may win, who you think
Yeah.
how like, and if these companies already own this data, right? Are they using that? Well, we wouldn't know, right? Or are they selling that
Yeah.
data? And these
hmm
these are kind of the
Yeah.
concerns when it comes to sports betting. Like, where do you what's your your stand on that? Do you see any concern with that as well?
Yeah. I don't know about from a sport betting. I think one of the most exciting things about sports is it is relatively unpredictable in a lot of ways. It just recently went through March Madness. And so, I mean, there were a couple teams that lost by a last second, 3-pointer or something like that. Really, really hard to predict. You know that it will happen somewhere, but it won't necessarily, you don't know which one it will. Um, there's a whole world around sports analytics. There's a great conference that happens at MIT every year where all of the people who are in this like world get together and talk about it. They are looking, primarily, at like three different areas. It's fan experience, player health, as well as player performance, and then like the business around it. Those kind of the three areas that all the sports stuff does. But it is almost ubiquitous now in almost every sport. I mean, I posted something on LinkedIn not that long ago around work that we were doing with the U.S. surf team that takes the video of the professional surfers, and I'm a big surfing fan. So, and when they're doing the turns and other like that, they can see that video. They can it be highlighted automatically for them, kind of what they're doing and what they need to work on, and they could talk about that with that coach at the end of the session. Like they do the session and at the end of the session. So every training session they get better and better. I think for me, what I've seen, and I think where analytics has really helped, is performance has steadily increased, right? You see like bigger and faster and more variety, and it ups everybody's strategy up because they're doing that. I actually think that makes it more difficult to predict because there's no kind of linear way that you can maybe extrapolate, just personal opinion, kind of where those are going to head because the complexity continues to grow. So I think there's a direct relationship there, but it has helped, I believe, a lot in something that I'm really passionate about, which is like player health. um, you know, Both my sons play soccer, and I've worked with a lot of professional sports teams before. And, the stresses that much more complex and complexity in sports brings because of the analytics, the stresses that brings on the body, it makes it so much more important to ensure that you're not, for example, wearing out a player who predictably could, snap their ACL or something like that. You can train them in a better, more efficient way rather than just, have them risk injury, and allow them to be able to play longer. So I think that's where it's really going to have. But then again, then the sports bettors are going to come in and they're going to make their bets, and there's collective what there who sometimes it's good, sometimes it's not good. So yeah.
So I have a question leaning more towards on the health side. So
Yeah.
exactly what you're saying with your sons playing soccer, precision medicine.
hmm
What is your thought on that? Where is that trend going? And are we seeing like there's just an unlimited amount of data that can be collected, right? So where are the big hot pockets? Like where are they collecting from that really matter and move the needle?
Yeah. So, and from a precision medicine perspective, I think two big things. One is moving data and combining it in the cloud and then sharing that broadly across an organization for life sciences companies primarily, and for providers as well. But, mostly we're seeing that in life sciences. That has been, we've seen just an explosion of growth there. And the reason why is because the process prior to that was much, much more time consuming. It was much more difficult. And it was a lot of like, what if, right? If this or that. With precision medicine, we have somewhat understanding of genetics, right? It's not perfect, but we have some. we wouldn't have been able to get there without massive compute, massive data, massive compute, right? We wouldn't even gotten to the point we are now where we understand a little bit, still much more to understand. But the other thing you could do is you can do very complex modeling, which was difficult before. You'd have to build some sort of supercomputer, and you'd have to go and generate large data sets or find large data sets, et cetera. So the fact that we now have the ability to store mass amounts of data in the cloud and process it has really helped our precision medicine. What we're seeing is there's an evolution now where a lot of our customers are using even things like generative AI to create complex protein folding structures, which allow and enable precision medicines that we may not have even thought of, right? So if you think of just real quick as generative AI or large language models, which we're seeing very popular right now, it's a reasoning engine. It makes connections based on the data that it feeds, through trillions of data points. And when you're thinking about like precision medicine, you need to make multiple connections between very complex systems and how they're going to interact. It's not far from perfect, but it's a really good place for a lot of our pharma customers are looking as how do they then use that as a starting point for research, right? For the chemists and biologists and others that they employ and doctors. So it's exciting because what I think is going to happen, just Peter's opinion, is we're going to see that accelerate at a much faster rate than we've seen before because we're giving tools to these researchers they've never had before, and the barrier to entry to using those tools are much lower than before. You don't need a team of data scientists, necessarily to be able to ask questions of a data set. You can go right to the research. And I think that's what's really, really exciting. It is causing a lot of our life sciences customers to rethink their data strategy and where they have stuff stored and moving more and more stuff to the cloud so they can take advantage of that.
That
And
makes a
kind of,
lot of sense.
yeah,
Yeah.
and kind of the leeway into that. Exactly what you were talking about. We're seeing with some of our clients, they're talking about, reducing the amount of trials that a drug will have to go through. So now they can start, having more different, not creating more than one at a time, right? Or they're like,
Yeah.
hey, now we can work on multiple different types of sets and have multiple different trials and put them in test environments to kind of understand how well they're going to fail or proceed
Mhm.
before even, putting them through trials. So we're having
Yeah.
drugs that might have gone through like 6 trials within, a couple of years. Now they're going through, maybe 3 trials, right? Cutting it down to
Right.
half the time, saving
Yep.
costs, investing that cost somewhere else. Are you kind of seeing that right now, or is that not happening
100%.
as of yet? Oh,
No,
okay.
100%. Every single customer and the life sciences I talk to is talking about that. It's a race right now for those. I'm not. There's only actually one customer I've talked to recently that wasn't headed down that path, and our advice was start heading down that path because everybody else is not necessarily as like a jump on the bandwagon. It's just they already a lot of value that the life sciences companies have seen from moving to that type of model. In fact, I believe it was FDA just approved like this year or last year one of the first kind of AI developed therapeutics on the market. And FDA, as amongst all of the bodies, is the strictest, one of the strictest, which is a good thing. And so the fact that they approved it is a huge deal for this whole area. And that is also, I think, spurred a lot of our customers to be like, okay, well, yeah, now this is real, and we got to go do that. Now, one word of caution: there is still a lot of question around, the ownership of what is output from a generative AI model. For example, the US Patent and Trademark Office recently came out and said any image or text that's produced from a GPT like algorithm isn't necessarily automatically copyrighted. So there's a lot of like, there's still people, they're still trying to figure it out. It's not definitive yet, but there's still a lot of like questions around who owns what comes out of a model like a generative AI. So what we work with our customers on is, well, I mean, we have a OpenAI API where I work now that allows you to kind of keep and retain and use whatever. But folks that are working in this space, there's still a lot of, it's so new, still a lot of questions around how it's going to impact the legal and a whole bunch of other different areas. So
I want another Peter opinion.
uh,
NVIDIA, okay? NVIDIA
yeah,
Cloud, GPU.
yeah.
What's Peter's opinion on that?
Yeah, no, I mean, NVIDIA is amazing, right? I mean, I can't speak highly enough. I have had the privilege of working directly with their CEO in past life. They're what people don't understand is like the large language models that we're seeing come out of OpenAI were all trained on huge banks of NVIDIA GPUs that was specially built by Microsoft for OpenAI, right? That's all public knowledge. It's like great. Their development that they have, the way that they think about, being able to process um, the large amounts of data, I think it's only a good thing. The more compute we can have out there, the better in my mind for, all different sorts of tasks. So Peter's opinion, like NVIDIA is a really great company. I think they're doing a lot of great stuff there. And that cloud that I saw that they launched is going to be great for, certain types of workloads for sure.
And I know this completely different topic, right? Another Peter opinion we definitely would love to hear though.
Oh boy.
So after COVID, we saw this large leap in companies going to sharing their data, right? And we have these companies like Snowflake who has the the Snowflake marketplace where you can sell your data off, right? And they're kind of
Oh
sharing
yeah.
data, right? But
Hmm.
Snowflake, even though they have a couple use cases, they're not haven't grown to a point where people are really using it, and they're more still using these hyperscalers for data sharing. Where do you kind of see this unstructured data being shared with your customers, and where do you see it kind of moving?
Yeah, I mean, I think the trends that I'm seeing is a lot of the customers, as they're moving their data to the cloud if they don't already have it. They're decommissioning kind of on-prem stuff and moving more to the cloud. That's a lot of the conversation we're having. Whether they're using what kind of unstructured data store like Snowflake or Databricks or Synapse or Redshift or any of the other ones, right? The Google's ones or whatever. Almost doesn't matter from a data sharing perspective. What I'm hearing is there's kind of two different things. One is the data sharing is really focused mostly on inside the organization. So you think about very large, complex multinational corporations or governments or things like that. The big thing they're doing after they're moving to the cloud is creating some sort of data marketplace or data mart to share data, but it's almost always internally because that's where they're going to get their initial, biggest lift, low hanging fruit, whatever you want to call it. Is just by having their organization be able to use all the data that they already have in a organized way. The second is around security, right? So making sure that data that is internal doesn't go outside if it's not supposed to. And so we're seeing a lot of the data sharing initiatives across these companies is really around an internal one. There's certainly data marts out there where people are, combining data and selling it, and those are kind of as a business. We're seeing that, but for the large multinational companies I work with, it's mostly about internal data sharing. The external stuff is usually if they're going to share pieces of data, not as like a whole, but pieces of data. So better customer interfaces, better analysis to be able to show the customer things like, for example, a utility showing a customer the projection of what they're going to spend as a result of like weather factors and stuff. Like they're sharing, their own analysis with that. That's what we're seeing a lot of. But other than those kind of three use cases, that's where we're seeing the majority of customers talking about data sharing.
And then last topic, back on the healthcare side of things,
Hmm.
payers are vertically integrating into health tech, med devices,
Yeah,
whatever. Where
it's pretty
they
cool.
have all this data. What's going on over there?
Yeah, I mean, with some of the payers, they're trying to do kind of two things with a lot of the data. One is have better patient outcomes, serve their customers better, and also they're trying to be as efficient as possible. What we're seeing in payers, for example, is things that used to take a week or two, when they apply a mentality of pulling their data in and doing the analysis of it, that drastically reduces the time they have to accomplish a particular task, process a claim, or approve something, and so forth, to hours or a day, right, with the medical personnel they have on staff versus weeks, which allows them to be a lot more efficient in what they're doing. So we also see them being able to tailor policies based to people based on that person's medical history, especially in like the Medicare space, right? So, being able to do that allows consumers to, save some money because they get the coverage they need, versus, right now where a lot of the benefits that people have in health insurance like largely goes unused in a lot of cases. So there's a lot of those types of efficiency plays that I'm seeing being done in the payer space for sure.
Wow, that's awesome.
Yeah.
Good to
Yeah.
hear.
And
Yeah.
we always like to kind of jump into this as like one of the last questions, right? So someone
Okay.
who's kind of getting into the field, right? What technologies would you recommend them to start learning in the beginning? What pathway would you guide them
Mhm.
on? What is from your own experience, being in the field for so long and understanding the field so well, where would you say for them to start and how to get to, maybe your level one day?
Yeah, absolutely. And I do a lot of mentoring, so I do talk to folks. I mean, for sure, if you're going to be like a data scientist, data engineer, some sort of computer science or training school or something like that, where you can like fundamentally understand these systems, absolutely is important. Get a certification in one of the clouds. They all have them. The certifications are pretty good. It also makes you very marketable, so you can get in and learn. And then, never stop learning. The thing that even I get surprised sometimes, even though I'm in the thick of it every single day, just learning about like new and different advances. And it's just I do a lot of reading. I spend my first 45 minutes of every day just reading various trade things, the archive server like papers and stuff like that, just trying to get a handle on where things are going. So, never stop is my advice. But to jump into it, it really is a lot around, positioning yourself where you can be hired and paid to continuously learn while you're doing the work is one of the best. And there's lots of, different opportunities out there. There's like a lack of folks who understand and know how to build and curate these types of things, especially around the data. And I would just encourage folks to buddy up with someone who's a little more senior and learn from them as much as possible. Get your hands on his stuff as much as possible. Certainly, things like Python is helpful. Any of the clouds is helpful. Understanding like large data stores like Databricks and other things like that are always helpful. But you can learn a lot about that stuff as you're implementing it as well. So that would be my advice.
Awesome. Well, Peter, thank you so much for, coming on. Do you have any last questions that you may have, Nate, before, we close it out?
I got a million questions, but I can't ask them here. So no, it's been
No
awesome,
worries.
Peter. Thank you so much. You're an absolute wealth of knowledge. Thanks for kind of clearing things up for us and for our audience. I mean, so insightful. It's unbelievable to talk to somebody who has so many years of experience in this type of stuff. So
Thank you. I appreciate it. Thanks for having me on.
Thanks for listening in to the Ocean of Technology podcast.
we post every Tuesday, so set your automations and hit that bell button.
Do you need a life jacket?
We have an extensive bench of onshore professionals ready to take your projects to the next level.
Because we solve problems.
Not just fill roles.
We are Ocean.